So in this video, I am going to show you on how to solve a non-exact equation. So we have here the example 3 times y raised to 4 plus 1 dx plus 4xy cubed dy is equals to 3. So first is we will factor this out. 3 times y fourth is y raised to 4 plus 3 times 1, which is 3 dx plus 4xy cubed dy is equals to 0. And then next is we will test the exactness of our two functions. So we have here the first function, our function of m of xy, and our function of n of xy. So in testing the exactness, we will first get the partial derivative of our m in terms of y. So the partial derivative of 3y raised to 4 plus 3 in terms of y is 12y cubed. And then the partial derivative of n in terms of x. The partial derivative of 4x y cubed in terms of x is 4y cubed. And then next is we will get the integrating factor. So in getting the integrating factor, we have here a formula. In case 1, we have 1 over m times the partial derivative of m in terms of y minus the partial derivative of n in terms of x to get the function f of x. And then in case 2, we have 1 over n times the partial derivative of m in terms of y minus the partial derivative of n in terms of x to get also the function of x. So in getting the integral of this formula, we can use e raised to, or in getting the integrating factor in this formula, we can use e raised to the integral of negative f of x dx. And in our case too, we can use e raised to the integral of f of x dx. So in this problem, we will try to use our case 2, which is 1 over n, 1 over our n, which is 4xy cubed. 4xy cubed times the partial derivative of m in terms of y, which is 2y cubed minus 4y cubed is equals to f of x. So next is subtract, since they have the same variable y cubed, so we can subtract it. 12 minus 4 is 8y cubed over our 4xy cubed. And then next is we can cancel this out. Our y cubed and 4, which is divisible by 8. So 8 divided 4 is 2. So the remaining value for our f of x is 2 over x. So next is we will get the integrating factor. We will use this formula, e raised to the integral of f of x dx. So our f of x is 2 over x. So e raised to 2 over x dx. So we can transfer outside the integral our constant, which is 2e raised to 2, the integral of 1 over x dx is equals to the integral of 1 over x dx is ln of x. So our our integrating factor is e raised to 2 ln of x to be x squared. So our integrating factor is x squared. Next is we will factor our integrating factor in each term of our equation. So we will rewrite our equation 3x or 3y raised to 4 plus 3 dx plus 4xy cubed dy is equals to 0. And so we will multiply our integrating factor in each term. So this will be 3x squared y raised to 4 plus 3x squared dx plus 4xy cubed times x squared will be 4x cubed y cubed dy is equals to 0. And the next is we will test the exactness of our general equation. So this will be our function of m of xy, and this will be our function of n xy. So in testing the exactness of this equation, we will get the partial derivative of our function m in terms of y. So the partial derivative of 3x squared y4 y raised to 4 plus 3x squared is 12x squared y cubed. And the partial derivative of our function n in terms of x is 12x squared y cubed. So therefore it is already an exact equation. And next is we will integrate our function m. So psi x dx is equals to our m, which is 3x squared y raised to 4 plus 3x squared dx, and add on our generic function in terms of y. So we will integrate this both. Our psi will be the integral of 3x squared y raised to 4 dx is x cubed y fourth, or y raised to 4, plus the integral of 3x squared dx will be 3x cubed over 3, or x cubed, plus our generic function in terms of y. Next is we will get the partial derivative of our psi in terms of y. So the partial derivative of x cubed y raised to 4 plus x cubed is 4x cubed y cubed. So this will be 0 because it has no y variable. So it is constant. Therefore, the derivative of constant is 0. And then plus the derivative of g of y, which is g prime of y. And equate this into our n, which is 4x cubed y cubed. So combine like terms, we can cancel out this, so the remaining value will be 0. So to get the g of y, we can integrate this both, so our g of y is equals to c. So substitute the g of y into our general equation to get the general solution to get the particular solution. So here our particular solution will be x cubed y raised to 4 plus x cubed is equals to c. And this will be our particular solution.